Hello guys, welcome back to my YouTube channel. We're dealing with question 6, which is function 2024 paper 1. Please subscribe to my YouTube channel if you have not subscribed, right? So question 6 reads as follow. In the diagram below, graph f of x is equal to minus x squared plus 4x plus 5 and g, a straight line are drawn. C is 3,8. It's a point of intersection f and g. As you can see, EH is drawn parallel to y-axis with E a point on F and H a point on G. Right, this is what we have there. Right. So given 6.1. 6.1 says calculate the coordinate of P, the turning point of F. Here it's a turning point, the coordinate of P, which you know is the turning point, and then it's a parabola, right? So since it's the parabola, we use the turning point. As if you know, right, you know we'll use the turning point formula. 6.1, we'll apply the turning point formula, which says x must equal to minus b over 2a, right? Then we know that this will equal to what is minus. Here we have given b it is 4 is positive 4, b is positive 4, a is minus 1. As you know our standard, right? Plus bx plus c, we use the standard. Our b there is 4, our a is minus 1, so our b will be minus 4 over 2, which is minus 1. A is minus 1, which is this will be equals to will equal to 2, which is the value of x, right? So we have find the value of x here is 2. It is 2, but we want the value of y again, the coordinates. So we'll substitute this to the original formula, right? So we'll substitute this to the original formula. We know that f of x is equals to minus x squared plus 4x plus c, plus 5, plus 5, then substitute 2 there. When you substitute 2 squared is plus 4, put 2 plus 5, then this will be equals to what? You punch that in the calculator, get that this is 9. Therefore the turning points, there is a coordinate is TP. You can just say therefore TP, which is, TP it is B. The coordinates will be 2 and 9. That is our coordinate is 2 and 9, that B. Right, 6.2 says show that the equation of a line AC, here it's AC there, show that is given by this. Is supposed to prove that, you're supposed to get that this line AC is equals to 2x plus 2. Want to prove that, okay, it's fine. But we know when you're telling this is a straight line, we have one point which is C there. We have a 1 point there, C. So you're supposed to have 2 points in the gradient. To calculate straight line, we're supposed to have a gradient and the 1 point, right? 1 point in the gradient. But now for us to have a gradient, we're supposed to have 2 points. We can use this point here at A is the intersection. You can see at point A, that is where we have our intersection there. So it is our intercept, which is an x-intercept at A. So we have the x-intercept there, 6.2. It's where we have x-intercept, right? We know that this is an x-intercept. We have an x-intercept there, right? So x-intercept, we know that y will be equal to 0. So x-intercept y will be equal to 0. As you can see, the point A is also the point where they intersect, where A, the graph of f also, you see this graph, both of them, they intersect there. So they will have the same point, they will share an x point there. So we know the graph of f, right, is given by, let us find the, you can say we know that is also the x-intercept of graph of f, whereby f of x is equals to minus x squared plus 4x plus 5. You know this will be equals to 0. We'll have minus x squared plus 4x plus 5. Then I will take this to the other side, will be positive squared minus 4x minus 5. I just transpose that. All right, I'm transposing those things there. This is what we have. This will be equals to 0. Right. So I'm transposing here. It's our standard formula there. As you can see, is minus x squared plus 4x plus 5. I'm just transposing those. Then x factorize x multiplied by x. I want to find minus 5. They were supposed to find two numbers, right? When we multiply, must give us minus 5, but when we add, we're supposed to get, when we add those values, we're supposed to get minus 4. All right, so what can be those values? Let's say, let me say minus 5 and 1. Minus 5 times 1, what will you have then? Minus 5 and 1 will have negative 5. But when we add this minus 5 plus this minus 5 plus 1, what we will get? We will get, when we add these two, we'll get minus 4. Whereby this is what we want there in the middle. Then that means we'll use these factors. We'll have minus 5 and we'll also have plus 1 there. This must be equals to 0. Right. So therefore x minus 5 is equals to 0, or x plus 1 is equals to 0. Then therefore x will be equals to positive 5, or x will be equal to minus 1. So but as you can see, point A lies on the negative, right? Lies on the negative side. This side is negative, this side going that way is negative, right? You can see that means our x there will be minus 1, because we'll decide, we will use this because it lies on the negative part, right? So, and therefore we can this is the point that we'll use. So then the point at A, you know that the point at A, the coordinate at A, supposed to be minus 1, 0. Remember, is the x-intercept, right? So we have that coordinate. So we have 2 points now, C and A, right? We have 2 points. We have point A, right, and point C. We have point A, which is -1, 0, and then we have point C there, which is 3 and 8. Here is 3 and 8. We have 3 and 8. So we have 2 points now. We can calculate this gradient. So easy now. You know the gradient will be equals to, you can see the gradient of AC must be equals to y2 minus y1 over x2 minus x1. So this can be x2 y1, y2 is 8 minus 0 over, there we have 3, x2 x1 is negative, that means will be -1. You put the brackets like that, then this will be equal to, punch that on your calculator, simply equals to 2. This is the gradient is 2. So we have the gradient. Can use a straight line formula. You know y minus y1 is equal to m right into x minus x1, or you can use this one, y is equal to mx plus c. It's a one and the same thing. You can use this if you want. It's a one and the same thing. So I will have y1. Remember here it's y1. We're using, it's up to you which coordinate you want to use. So I'll use this coordinate. It's up to you which point you want to use. I use point 1, right? Point 1, which is, I'll say I'll use the point A, which y there, y value there is 0, x is -1. So y value here is 0. The gradient is 2. We've calculated it. Minus, then -1. Remember, this is our point there. It's -1 and 0. I used point A, then this will be y. This will be 2 into x, then distribute, that will be +1. Then this is what we have, y. Distribute this 2 will be 2x, right, will be 2x plus 2. So we have proven what they said we should. We have proven what they said we should prove. Right, this is what they wanted there. We have shown that g of x is equals to 2x plus 2. You can say therefore g of x, as they've written there, g of x is equals to 2x plus 2. So yeah, that is how we go about. Then 6.3. 6.3, as you can see, it says calculate the maximum length of for f is greater than what? G. Calculate the maximum length of here, this one, the dotted one, that we want that maximum length for f is greater than g. Fine, is what we know. So this, you have learned about this. We have learned about this. To find the maximum length, we're supposed to use, you must know always when you see things like maximum, nearest, smallest, use the turning point formula, or it's a first derivative. It's at the turning point. It's actually, if it is a parabola, the maximum occurs at the turning point, and the minimum occurs also at the turning point if you are dealing with a parabola. Also, when you are dealing with the cubic, also minimum and maximum, it's when it occurs at the turning points It's where the turning point of the something that we call it minimum or smallest. Those things you'll see. It's simply just a first derivative, right? So yeah. 6.3, right? We have 6.3. When we're talking about the maximum, if you see this way, it's maximum, minimum, nearest, least, all those things, nearest, things like this, nearest, biggest, all these things, biggest. Yeah, we must know we're talking about the first derivative. It's a turning point. First derivative, you're supposed to take a first derivative. All of these things you're supposed to take. It's a first derivative. Let me just say dy, or let me just say will be a first derivative. All of these things, just a first derivative. First derivative. It's a turning point when we're talking about maximum. Remember the maximum of the parabola, it's here. The minimum is like this. Then of a cubic, it's at the turning point. Actually, the minimum and the maximum, it's at the turning point. But when you hear those words, we're simply talking about the turning point. Remember, a first derivative, it's a turning point. Another formula for first derivative, you can use this thing. It's a turning point. It's a one and the same thing. It's a turning point, right? You find the value there at the turning point, yeah, which is a gradient turning point. So yeah, this is what you're supposed to know in when we're talking about those things. So yeah, so supposed to then you say they say the maximum length of EH, right? EH is then can say EH will be equal that you take the length of the top, the one that is on the top, your one H, it's HF, it's f of x, then you subtract g of x, then this will be simply equals to f of x minus g of x. Then you substitute they are equations. We know that the equations, the one that we have calculated, right, which is minus x squared of g of x is minus x squared, right, plus 4x plus 5, right? This is what we have raising it. Then minus, we have calculated this one of g of x, but because there are two terms, put a parenthesis or a bracket, 2x plus 2. This is what you have right there. This is what you will have. Then this simplify further will be minus x squared plus 4x plus 5. Distribute the negative will be minus 2x. Distribute, there will be minus 2, right? So let's group the like terms. 4x minus 2x will simply equals to just 2x, right? Will be plus 2x positive 5 minus 2 will be simply equals to minus 3. This is what we have. This is, remember, this is our EH. See what do we have here? Be careful. This is what you see what we have there. This is a parabola. So what I've told you, this is a parabola. Since it's a parabola, they say they want the minimum. I said we talk it's when the length, you find it using the turning point. You're supposed to find the x value at the must use the x value at the turning point. At the turning point, it's where we find the maximum value or the minimum value. At the turning point is what I've said. So this is simply as, yeah, it is nothing, simply the same is like this. minus b over 2a. We know at the turning point, minus our b here is 2, then we have a. This is what we have, right? So this will be equals to what? Simply this will simply equals to 1. As you can see there, this will simply equals to 1. This simply equals to 1. That is the value of what? Of x at the maximum. Now we want the distance. You take this, you substitute it back here. Remember, we have found that value of x at the turning point, right? Now we know at our maximum, EH will be equal to minus, where we see x, we replace it with what? With 1 squared plus 2, we replace that with 1 minus 3. Then this will be equals to 4 units. This is 4 units. We have 4 units. So this is what we have, 4 units. That means therefore our maximum length, we know our maximum length, max length is simply just equals to EH, whereby it's equals to 4 units. Yeah, at f of x is greater than g of x, right? But your final answer, if you end it here, you'll get your full marks. I'm just explaining further there. It's one and the same thing. So yeah, this is what you're supposed to know. It's 4 units. That will be our maximum length. So we have found that our maximum length is 4 units. So 6.4. Yes, 6.4. Let's check that we are given. This says k of x is equal to g of x plus m is equal to minus x squared minus 2mx minus 2m squared plus 4x plus m plus 4m plus k. It says determine the value of m such that g is a tangent to k. You see, such that g is a tangent to k. Right. You must understand it there. They say, check this statement such that g is a tangent to k. If g is a tangent to k, remember, if you have, let's say example, if you have a graph like this, then there is a tangent. They intersect. If they intersection, that means this graph, they will be equal because they intersect, they touch. There's an intersection there. Then in such a way, from this statement, it clearly shows that g will be equals to k. That graph, that will be g of x will be equal to g of k. As you can see, just from that statement, you can see that g of x will be equal to k of x. From this statement, or just reading from this statement, you can simply see that that is what we can have then. So we'll know that. So says determine that, okay, we can equate that. So we know that our g of x will be equal to k of x. Right. G of x is the straight line. We know that we've calculated the straight line, whereby the formula of the straight line we said is 2x plus 2. We did calculate this, 2x plus 2. What about k of x? They have given us here. As you can see, they said k of x is equal to this. Here is a k of x, right, is equals to that, where f is that as you can see. So you may quickly since you've seen that means k of x is the same as that as f of x. K of x is the same as f of x plus m. So this thing is a one and the same thing. So since they are equal, you can simply we know that we have given that is minus, they say that is minus 2x squared minus 2mx minus m squared plus 4x, right, plus 4m plus 5. This is the equation that we have there. So let us solve. I will take the like terms, let us solve. You will see what we go about. Can take all of these, can transpose it to this side, right? If you transpose that, you'll have 2x plus 2, right? Transpose this will be plus 2x squared, and also transpose that will be plus 2mx. Then I transpose this will be plus m squared, and also that will be minus 4x. Transpose that will be minus 4m. Transpose that will be minus 5. This will be equals to 0. This is what we have now. Here minus 4x, and this will be like terms, like when you take these 2x minus 4, right? As you can see there, 2x minus 4, which is will be minus 2. So that is what we have there. That is what we have there, right? So also other terms there, we have these other like terms, as you can see there. So yeah, also here we have common, as you can see there, we have a common, we have 2 and 2 is common, x and x is common. So let's see how we go about this. Let's see how we can go about this here. Let me check, I've taken this correct. Is not, is minus 1. Also that is minus, it's minus 1. So here this is minus 1, not minus 2. Okay, this is negative 1. It's negative 1. Yeah, that is negative 1, right? So simply that means this will be positive 1. Sorry about that. So let us try and group. I'll start by highest degree, a squared. We have that. Here I have this term plus 2mx plus, what is that? We have these 2. If we punched this, 2x minus that minus 4x, right, is our terms there. So we're supposed to have our thing there. We know that will be simply equals to minus 2. This will be minus 2x. This one, we are done with that. Then we come to the constant will be minus what? Minus 3. But we have that, isn't it? Minus 3. Also we have 4m, we have minus 4m, minus 4m here. I want to take it in standard form. Then this and this, and 2 will be minus 3. Then obviously here we have 0. We have m squared at the end. Where it's m squared, supposed to have, with our m squared is x squared plus 2mx minus 2x minus 4 m squared. Here it's our m squared. I suppose so about this, where it's m squared. Here we have m squared plus m squared here. So we are done with m squared minus 4m minus 3 is equals to 0. Right, this is what you'll have. So this is what we will have there. So we have here x squared. This is what we have, but if you check here, we have a common. Our common here, we have the common thing there. There's something that which is common. If you can check here, x and x also 2 is common, but I just want to take out, let me just take out x. I know I will tell you why I'm taking this. Will be 2m, right, minus 2. Then I take out x as a common factor like that. Here we're left with what? With plus m squared. Here I have minus 4m minus 3 is equals to 0. Why I did this is because I want to use, because the standard form of a quadratic is a the standard form, as you know, the standard form is there is x, isn't it? We want to use the standard form. I just made a standard form, as you know, ax squared plus bx plus c. So this x will represent that the b will be what is inside the bracket. So I did this. You see, that is why I just took out the x alone, so that I'll maintain a standard form. So yeah, because now remember, now we did this, we are done with this part here, of this part here, we did that. But now we should determine the value of m. We want the value of m, and then this is the tangent, and then tangent has one, it has one. If you have a tangent, it has one contact, one solution there. And then if we have equal, if we have equal one solution or equal roots, it has equal roots or one root there, we know that we'll use it's when our, so about it's when our delta is equals to 0. Remember your nature of roots. It's when our delta is equal to what? Is equal to 0. So yeah, so and that is a tangent. So it's when our delta is equal to, as you can see, our delta must be equals to 0. So our delta we know is b squared minus 4ac must be equals to 0. What is b? Here is b. I said this is the standard. B represent all of these inside the bracket. This is b, right? As you can see there, will be, put your brackets, 2m minus 2, you square that, minus 4. Our a is 1 here. So you can see we have 1. But our c, it's all of this. That is c. That is our c. Do not panic. It's all of that, which is m squared minus 4 m minus 3. Then here all of these must equal to 0. Then here is your math. Now simply just simplify. If you simply just do your simplification, if you simplify this, what we have here, just simplify this. This is a perfect square. We know square the first one. I'll square the first one will be 4. Then I square m will be m squared. Then I multiply by the 2. Also I multiply the 2 and I add by what I've multiplied. I will multiply the 2. When I multiply the 2, that will give me minus 4m. I also add this, what I've multiplied by it. Then will be what? Minus 8. If I add, like, I will add that. I add minus 4m. So this will be minus 8. Minus 8m. Right. Then I square the last, including the sign. If I square that, will be what? 4. Just square that. The last one will be plus 4. We are done with that part. Then here, let's check. There we have minus, multiply, we'll have 4. We'll have 4 like this. Then you have m squared minus 4, m minus 3 is equals to 0. Then here you still have this, m squared minus 8m plus 4. Then distribute this, will be minus 4m squared. Distribute that, will be plus 4m. Oh no, 4 times 4, which is 16m. Distribute that, will be 12, positive 12. 4 times negative 4 times negative 3 will be just positive 12. All this equals to 0, isn't it? Then as you can see, this and this will cancel, right? Then you'll, yeah, that and that will cancel. As you can see, that and that will cancel. It's what we'll have now. Here we'll have, you're left with minus 8m, right? These and these are like terms, will be plus 16m plus 4 here plus 12, which is equal to 0. This will simply just equal to what? This minus 8m plus 16 will be simply equals to what? Simply equals to 8m. Simply equals to 8m. Then you add these two, simply 16 will be plus 16. Then this is equal to 0. Then we'll have 8m. Take that to the other side, or you would be minus 16. You divide by 8 both sides. That and that will cancel. Then our m will be equal to what? Minus 2. Right. This is our m. Then we are done with this question. All of these steps that you're supposed to take to find the value of m. Now we have answered this question. Now we have just answered this question. We have found the value of m. Yeah, we are done. Thank you guys for your time. Please do not forget to subscribe to my YouTube channel and click that notification button, and you can share this video to your fellow classmates, and then you can comment and share. Thank you for watching.